Hello everybody, today we will be going over a quadratic function problem at the IB Math Studies level, which is actually disguised into a systems of equation problem. But anyway, we have the graph of a quadratic function which is shown right here, and for part A, we need to find the equation of the quadratic function in the form y equals ax plus bx plus 30, right? And so of course, how the heck do we do that? Before we jump into how we do that, it's very important to have clear like what we know about the graph, right? So we know that the y-intercept is 30. We know that we have the points 3 comma 0 and the point 5 comma 0, which are the x-intercepts here and here. And so when in doubt, just plug and chug and see what happens. So first I will plug in 3 comma 0 into the formula that was given. For y I have 0. For x I have 3, so it's going to be a times 3 squared plus 3b plus 30. And this bad boy turns into 9a plus 3b plus 30. This whole thing equaling 0. Now I'm going to plug in the other set of points, 5, 0. We have y equals 0 and x equals 5, so it ends up as a times 5 squared plus 5b plus 30. So working this out a little bit, we end up with 25a plus 5b plus 30 equals 0. And so now we have our two lines with what we plugged in. So if I combine them real quick, I mean, not exactly combine, but if I put them next to each other, right? We now see that we have a system of equations. And with a system of equations, the two ways you can solve it are with elimination or substitution. In this scenario, I'm going to choose elimination, but if you really like substitution, you can see how I do it at the end of the video. So I'm going to choose to multiply the top guy by -5 and the guy in the bottom by 3. Why am I doing this? So that my b's cancel out, okay? How do I know that this is going to work? Well, because if I look at the multiples of 3, and by multiples I mean 3 times 1, 3 times 2, which is 6, times 3, which is 9, times 4, 12, and the multiples of 5, I see that eventually they have a common multiple, which would be 15. So I want to make them both 15, one of them be positive, the other one negative, so that they cancel out. This is the method of elimination. Having this in mind, the equation on the top turns into -45a minus 15b minus 150 equals 0, of course. And on the bottom, 75a minus 50, plus 15b plus 90 equals 0. And as I said before, my b's are going to cancel out, and my a's end up being 30a minus 60 equals 0. I want to get a alone, so this turns into 30a equals 60, and now a equals 2. And now that I have one of the values, or one of the variables better said, I can plug it in back into either of these, and get the value for b. I'm going to choose to plug it in into the one on the top. So working that out over here, we know that plugging 2 for a, 9 times 2, plus 3b, plus 30, equals 0. 18 plus 3b, plus 30, equals 0. I combine the 30 and the 18, we have 48, plus 3b, equals 0. So I want to get b alone. I do negative 48 on both sides. B equals negative 16. And so, for part A, the equation of the quadratic function, if I plug everything in, is going to end up looking like this. If a equals 2 and if b equals negative 16, we know that the formula is going to be like this. Y equals 2x squared minus 16x plus 30. And we can always double check this by graphing. But anyway, that is part A. Now for part B, we open up the formula booklet. Trusty rusty formula booklet. It's worth it to get familiar with. And we know that for quadratic functions, it gives us that the axis of symmetry is going to be negative b over 2a. And so now you just gotta trust the formula, plug in what we got for b, plug in what we got for a, and it ends up looking like this. Negative 16 over 2 times 2. In other words, we have 16 divided by 4, which means that the axis of symmetry is 4. What does this mean exactly? That on x equals 4 is the axis of symmetry. This is how we read the answer or the formula. And so if we come back to the graph for a second, knowing that the axis of symmetry is indeed 4, we draw it on our graph and see if it makes sense. And so we go to the point 4, which would be somewhere here, and we see that it nicely cuts the graph right down the middle. And so this is one visual way to make sure that the axis of symmetry is actually correct. The other one is simply checking your answer, checking your math. You can always graph it and see if it makes sense. But visually appealing, it makes sense. So we are convinced that this is the answer. Anyway, this is how you do this problem, and I hope it helped.